afternoon, one and all. The subject name is compiler design. In this subject, we have discussed some of the new concepts, problem solving techniques in parser cases. One of the problems is SLR and LR parsers. In the previous videos we discussed it. Now in this we can see CLR and LALR parsers with the help of a exam. So CLR parser is nothing but canonical look ahead parser. This is called C stands for canonical and L stands for left to right and R stands for rightmost derivation in the reverse. So here, in order to implement this CLR parsing, we have to verify first the ambiguity step, first step, and second step we have to implement the argument production, and third step we have to perform canonical collections, and in the fourth step write the data flow diagram. In the fifth step we have to write the parsing table. So these are the steps that is to be implemented. First, verify this context free grammar and free ambiguousness for the given example. We know that these steps are already known, and canonical collection of 0 items can be obtained by implementing the LR0 plus look ahead. So here the important additional of the previous two parser is look ahead is to be implemented. The look ahead can be obtained by writing this LR of 0 items with the help of look ahead. That means where the final item is to be required, and we are going to add a dollar symbol for the argument of each of the production where look ahead is to be required. So here this is the example that is to be considered to solve the CLR grammar. So in this grammar the productions are given one, that is AA, address AA and B. So we know that the augment production by inserting this dollar symbol for each of the cases, but the dollar is to be included for this one, and also the corresponding look ahead is to be included. Why? Because here the augment production is to be with this one. Similarly, that with here we have to consider this as A or B. Why? Because the follow determination of this A, which requires this look ahead AB. Similarly, this one also AB. Now this after verifying this one, these are to be added, comma separated, followed by look aheads for each of the production. So these are to be added for each productions one by one. So the remaining working functionality is same as previous example. So that is the determination of closure of I0. So I0 is to be implemented with this one, that is S. What are the S performing? A, or write the productions of A. So like this, these two carry out this one. And similarly, you have to perform once again I0 with capital S, I0 with capital A, and I0 small a, I0 with small b. So like this, we have to perform the closure that each of the operation, capital S, capital A, and we are going to reach the next. So that is to be implemented with the help of this data flow diagram. So these are the given one. Capital S, which reaches to the I1, state I1. Capital A, which reaches to the state a new state. Why? Because here the first one is S derives S dot. So it reaches to the end. And the dollar symbol is also available at the look ahead at the end of this one. Comma separated dollar. So this is the end of the production which is reached I1. Whereas whereas the next production that is to be considered as S implies dot AA. So here in this case, a closure, if you perform I0 comma A, then this results a new state that is S implies that is A dot A comma dollar. So here the variable that appears is capital A. So the list out productions which are written the capital A can be A dot AA, A derives dot. And here we have to write the look aheads which contain the same. So that is the one of the difference. And for this I0 first, second completed, and with the third one, A derives small a capital A, comma AB. For this, if you apply, that is I naught with small a, then it reaches a new state which contains small a dot capital A. Look ahead is A, B. And but for the variable which is to be appears are still two more productions are there, dot A and dot B. We have to write the production look ahead is with the same. Now this is a new state that is to be generated, that is called as I3. So I have reached this. This one is a new state I2 and this one is a new state I3. And the last one, if you perform A derives B, A derives dot B, comma A by B. So this is the rule which contains I naught. If you perform I naught closure B, we reach to end, that is a B dot, comma separated, look ahead AB. So this is the new state, but this does not move with the another square. It stops the procedure at this point. So we have generated a new state I1, I2, I3, I4 from I0. From I0 we have generated a new states with the help of closures. So but out of these four states, I1 is and I4, these are all not processed further because it reached the end. So we have to process once again I2 and I3. So these two states still the same procedure which applied previously, that is capital A, which reached to some new state I5. Why? Because the dot is reached at the end, so we can stop here. But with small a, once again it reached a new state, that is I6. Small b, it reached to a new state, that is I7. And I3, if you observe I3, that the new state that is reached to I8. Why? Because with small a, with capital A, it reached to new state. But with small a, new self loop, with small b, I4 only it reached. I2 with capital A, new state, small a, it is I5 is reached, and in this new generator I6, I7. So I6, which with the small a self loop, capital A new state generated, that is I9, small b with new state, same state, that is I7 only. So what is the rule that is available in I9 is A derives A dot. So this is the end of this process, then we can stop the procedure. So we can implement a pass table mechanism. So this is the given grammars. In this, we have to previously have written a data flow diagram. The same diagram can be helped with the help of CLR implementation. In CLR implementation, you have to write the terminals capital S. Capital A is the terminals that are available, and small a, small b, dollar. These are to be written as a left hand side with the column notation, and the states are I0, I1, I2, I3, so on up to I9. 9 states are generated. Out of 9 states, I0, what is the S? S, it is reached to the one state, and capital A, it is reached to 2, and with small a, S3, S4, that is first I0, and I1, from I1 there is no further state, it is the accepting state, that is dollar. Whereas I2, if you consider capital A reaching to the state 5, so that's why capital A5, here capital A, here's capital S. So it is reached to the 5 with I2. Now with small a, small b. So small a reached to 6, so S6, small b reached to 7, that is S7. As if you consider to the I3, I3 with capital A reached to the 8, so that's why 8. And the small a refers to the self loop, that means same state S3, and small b which reached to the 4, S4. And I4 is a reduction step. For this there is no further. And I5 is also a reduction step. And I6, if we consider small a reached to the same, so that's why it is S6. And capital A, I9, it is reaching, so the 9 on the below column of A, we have to write 9. and small b reached to the S7, so we have to write 7 as S7, and I7 is also a terminating step, there is no further, and I8 is also a reduction step. I9, why? Because the symbol is reached at the end, from that there is no transition takes place. So these I4, I7, I8, 4, 5, 7, 8, 9 can be processed with this help of the given grammars, that is 0, 1, 2, 3. So I4, the production which contains A derives B. So A derives B, that is R3, R2, R1. So here I4 which contains production A derives B dot. So this is to be considered as reduction step R3. So that's why R3 is to be used as a this one. And follow of A we have to consider, that is AB. Whereas I5 is also a reduction step. I5 contains S derives AA dot. Now this S derives AA dot, which is to be included in R1. So that is to be as R1 as dollar, because this is the follow of this S. And I7 A derives B dot. So this is to be considered as R3. So I7 R3 dollar, follow of A. And I8 I9. I8 is A derives small a, that is R2. AB, follow of A. Follow of this. I have to consider this implementation with follow of the notations. And then last I9. I9 is the step that is A derives A small a capital A dot. So that is R2. R2 is to be written as, that is dollar, with the follow of operation of follow. Now the difference between the CLR and LAR table, which you have included the small, we have to process all the steps simultaneously up to data flow diagram. This is the data flow diagram which we got from this CLR. Now from this CLR we are going to get this the LALR, that is LALR means look ahead LR. So look ahead LR, which gives a determination indicating that the states which are common to the states common, which contains the rules that are common, but look aheads are different, can be included as a one state. Can be included as one state. Where so here if you consider I1, this is a one state. I0 is one state. I2, I3, I4, I5, I6, 7, 8, 9. But I0, which contains the rules which are available, is there in that no other states does not contain. So that is to be kept as it is. I1 is also a state which contain a rule which doesn't contain any of that one. So I have to process the same. I2 is also a state which you have to process the same thing. I3 and 6, if you observe the I3 and I6, so here I3 which contains the rules, I6 which also contain the same rules, but lookouts are different. That means I3 contains small a, capital A derives dot A, capital A derives dot B. Now in this case, the lookout is AB, here also AB, here also AB. This is I3. Whereas I4 also I6 also contains same, but lookouts are different. So that's why here this I6 and A dot A dot A, that is A dot A derives dot B. So here lookouts are different, dollar only. Remaining things are to be same. So that is to be processed with the same result of the information or not, we have to. So the states are to be written as combinedly 3, 6. And similarly 4, if you observe I4 is the state which contains the single rule production, that is A derives B. Only look ahead is A slash B. A slash B is the ARB is the look ahead. Now this I4 and 7. I7 is also which contains the same production A derives B dot. Look ahead is dollar. So these two can be combined and written as I47. And 3 we have processed 2, 3, 4, 5, 5. I5 is the state which contains but it doesn't contain any option, so we have to process the same. Whereas I8, I9 also, if you observe, these two are same. I8, I9 also A derives I8 which contains A derives small a capital A dot. Look at it is AB. And I9 is also a state which contains the rule A derives small a capital A dot. Look at it is dollar. So now we are going to combine these two states I8, 9. Why? Because the lookouts are different and the rules are same. And still there are no further rules. So the remaining process is same for combining this one. So here that's why in the previous table we have combined the two states where the corresponding rows I0 to I9, I1, I2, but in case of I3 we have to write I3, 6, and in case of 4 we have to write 4, 7, and in the last we have to write 8, 9. Now remaining states has to be single, we have to write completely 1, 2, 3, 1, 2, 5. So that means here we have to process the entries in the same way, but the combined states where suppose if here in the case S3, S4, now this S3 where appears we have to write 3, 6 because the state is combined. So that's why it is 3, 6, 4, 7. Where 4 appears we have to write 4, 7 because the state name is combined together writing as 4, 7. Like this we have to write the entries with the same as data which is. But the reduction step, suppose for example 3, 6, 4, 7. So this is the row 4 which is to be available and this is the 7 which is to be included. Now these two combined we will get R3 4, 7 as R3, R3 column A, column B also R3 and the dollar is also R3. So like this we can complete this reduction steps with easily with the corresponding. So only the minor differences we have to verify whether any states of possibilities occurrence with the same rules and different lookouts. So such cases are to be handled with the combined representation of the states and that is to be implemented with the parse table also, writing this combined state as I suffix 3, 6 and the where 3 appears we have to write that 3, 6, where 4 appears 4, 7, where 8 or 9 appears 8, 9. So and we have to combine the each rows also and the parse table combined together will be written as like this. So in this way we are going to solve the corresponding CLR and LALR parsing tables and data flow diagrams with this example. Thank you. We will come up with one more new problem solving techniques or other concepts. With this we can end up the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.